I hope you guys had a pleasant homecoming weekend, and I'm going to take a few minutes, and by few I mean few, to work out this key for this practice quiz for you. So let's get started. The first question asks you to calculate several densities. Density, hope you know by now, is the mass over the volume. So I'm just going to take, in each case, the mass divided by the volume, and then use my appropriate number of significant figures, which in this case is 3, since the volumes are each confined to 3 significant digits. Your units in each of these cases should be grams per mil, which should be written after each of your numbers or on the top of the table here. So we have 2.5, excuse me, we have 21.5, 23.0, 21.8, and 18.9. Now we can move down to number 2, and it says that the suspected samples are metals of platinum, which has a reported density of 21.45. Were the results accurate? Were they precise? Explain completely. Now when we talk about precision, we're talking about are all the measures that we got close together. Clearly, with this variety in our densities, they are not, so our precision was very poor. But as far as accuracy, we have the measured accepted value down here of 21.45, which is pretty darn close to this one and number 3. So those two measures could be considered accurate, but the overall precision of the experiment was poor. In number 3, it asks us to calculate the average density from the 4 trials, for which, of course, you have to take all of these 4 numbers and divide by 4. Now that 4, since there is exactly 4 numbers, has an infinite number of significant figures, and therefore you should not be using that to decrease the number of significant figures in your answer. So what we end up with here is an average of 21.3 grams per mil. And again, you need to keep all 3 of those significant figures. Now when we go to calculate the average density, we need to take the experimental value, which is 21.3, minus the accepted value, 21.45. We need the absolute value of that number divided again by the accepted value or reported value, 21.45. This is a percent, so of course we have to multiply it by 100, and your answer is 0.7%. Now you may be wondering why I rounded this to one significant figure when I have 3 here and 3 here and 3 here. And that is because once you subtract 21.3, or once you subtract 21.45 from 21.3, you really end up with one significant figure on the top. Then you do your division, and you have to stick with one significant figure in your answer. So, actually, this whole thing needs to go down here. Okay, on to the next question, which is about human body temperature. Wants us to convert to kelvins. Kelvins equals Celsius degrees plus 273. So all we have to do is add those together, and you will get an answer of 310 kelvins. I put this little line here because I want to indicate that that is still a significant figure. On to the next page, another conversion. This one is going the opposite way. It's going from kelvins to Celsius, and so we need to take 5,800 kelvins minus 273 this time, and you get an answer of 5527 degrees Celsius. This needs to be rounded now since you're subtracting. These two zeros are not significant. I need to round this answer to 5,500 to respect my significant figures. Now in the next couple, we're talking about scientific notation and maintenance of significant figures. And I'm just going to go ahead and record these to save us a little time, hopefully, on our recording length. I hope that's what you got for your answers on that. And now for our addition, subtraction, multiplication, and division, and keeping, of course, our answers rounded to the appropriate number of significant figures. Here we're adding and subtracting. You can see our least precise goes to the 10th, so we also need to go to the 10th, and this is a measure of volume. Here we're subtracting, and you can see in this number our least precise actually goes to the hundreds place, and therefore I rounded my answer to the hundreds place as well. And of course this is a length. Now we have a division, and we have 4 sig figs on the top, 2 on the bottom, so of course I'm going to round my answer to 2 significant figures, and this is grams per centimeter cubed, which is a measure of density. Another multiplication problem now. We're just going to throw these in the calculator. Notice this number only has 1 significant figure, so your answer, your final answer, should be rounded to 5,000 centimeters cubed, and this is another measure of volume. Finally, we have 2 different operations. Here we have a subtraction on the top and then a division, and if you round this out here, once you subtract on the top, you're going to be limited to 1 significant figure. Plug it in your calculator and check it out. Then once we do the division, of course, our final answer, we have to respect that 1 significant figure on top, and you should have an answer of 2 grams per mil, which is again a measure of density. Okay, I hope you're all set, and we'll see you folks all on Monday.